Hello, my name is Omar Shini, and in this video, I'll be explaining a topic 6, paper 2 past paper question. Um, as you can see here, I can't include the actual question due to copyright reasons, so I've included the test code up here if you'd like to follow along with me. Now, the question states, the thermal decomposition of dinitrogen monoxide occurs according to the equation 2NO2 gas turns into 2NO2, 2N2 gas plus O2 gas, which is basically nitrogen gas and oxygen gas. The reaction can be followed by measuring the change in total pressure at constant pressure with time. And this is the graph right here. The x-axis and y-axis are shown with arbitrary units. Explain why, as the reaction proceeds, the pressure increases by the amount shown. So as you can see here, the pressure starts off at 200 and it goes up to 300. Now, why is that? So, as you can see here in the equation, we have this 2NO2, N2O, which is the dinitrogen monoxide, which it has two, let's call it moles. So we have 2 moles of this here, but on the right side, we have 3 moles of the 2 N2 gas, which is nitrogen gas, and the 1 mole of the oxygen gas. So that means that the total number of molecules has increased. And since the number of molecules has increased, that means that the pressure has increased. So, so that would mean that, which means up of the pressure. So that answers the first part of the question, that the pressure increases. But the question also asks why it increases. So if we take the 3 on the product side over the 2 on the reactant side, that will give us 1.5 times 100 gives us 150%. Now, if we subtract that by 100%, we'll get a 50% increase from 2 to 3. Now, if we were to do the same thing with the pressure here, the 300 over 200, that would also equal 1.5 times 100 minus 100%, which is also equal to 50%. And this is why the pressure increases by that amount, because the amount of molecules is proportional to the pressure. The second part of the question says, outline, in terms of collision theory, how a decrease in pressure would affect the rate of reaction. Now, as you know, collision theory is that for a reaction to occur, particles must collide with sufficient energy and the correct orientation. Now, if we were to decrease the pressure, that would mean that there would be more space between the particles. So let's say this is a particle, this is a particle, this is a particle. As the pressure starts to decrease, the particles will begin to spread out like this, meaning that there's less collisions, because if these guys, for example, were going in this direction, they would collide with this one, and then this one, it would just be a lot of collisions. But when they're spread out, they would have to collide here and then bounce and then hopefully find another one. So there's a lot more space for the between the particles, and this will cause fewer collisions. And as you know, as I previously mentioned, the collision theory is that for a reaction to occur, particles must collide. So since there aren't as many collisions, a decrease in pressure would reduce the rate of reaction because there would be more space between the particles and fewer collisions taking place. Part C of the question asks, the experiment is repeated using the same amount of dinitrogen monoxide in the same apparatus but lower temperature. Sketch the graph you would expect. Now, referring back to collision theory, a lower temperature would mean that not as many molecules would have a high enough energy to react. And lowering the temperature also means that the rate of reaction would be lower. Um, Temperature also is linked to kinetic energy, and since there is more kinetic energy when the temperature is high, that means that there's more pressure. So when the temperature is lower, that means there's less pressure. So if we were to draw a line, we would probably start somewhere lower, and the curve wouldn't be as steep because the rate of reaction is lower due to the smaller temperature. So it should look something like this. Of course, since I'm on a laptop, it's really hard to make this straight, but of course, on an actual exam, you should make this straight. Now, it doesn't reach the same height as this line right here because not as many particles, because, sorry, the lower temperature means that the pressure won't be as high. So this line can never reach this line unless more molecules are added or the temperature is increased. Part D asks, the experiment gave an error in the rate because the pressure gauge was inaccurate. Outline whether repeating the experiment using the same apparatus and averaging the results would reduce the error. Now, let's draw the pressure gauge really quickly. Sorry for this really bad drawing. And this is 0, and this is where the arrow is. Now, whatever value you have for the experiment, the pressure gauge would be off. So let's say this is the actual result, but the pressure gauge is here. If we were to repeat the experiment, and for example, the result was now here, the pressure gauge would still point the arrow a little bit to the right. And that means that no matter how many times you repeat the experiment, the results will always be skewed because it is a systematic error, and no amount of trials would reduce this error. The final part of the question states, the graph below shows the Maxwell-Boltzmann distribution of molecular energies at a particular temperature. The rate at which dinitrogen monoxide decomposes is significantly increased by a metal oxide catalyst. Annotate and use the graph to outline why the catalyst has this effect. Now, the Maxwell-Boltzmann curve shows the number of particles on the y-axis and the kinetic energy on the x-axis. Now, the more you go to the right, the more the x-axis increases, the more energy the particles have. So let's say in this reaction, the activation energy is right here. Now, as you know, a catalyst decreases the activation energy by providing an alternate pathway. So whenever there's a catalyst, the energy is going to decrease. So here, as shown by here, lower energy. Now, as you can see, EA with catalyst. Now, as you can see, there are more particles here in all of this part than there were before at just this part, meaning that more particles or more molecules have the activation energy, and therefore more molecules will participate in the reaction when there is a catalyst, and the rate of reaction will be increased. Thank you for watching. I hope this video was beneficial, and have a great rest of your day or night. Bye.